I'm Michael Kelley. I am a researcher at the University of Maryland in College Park.
Yes.
Maybe one, two, together. One, two, three. Just right. Well,
Yeah.
closer. 1, 2, 3. Great. Thank you. Thank you so much.
Yeah, so what I like to study are comets. The best thing about comets is that they are preserved pieces of our early solar system. So they have kept they have kept pieces of the outer solar system that we would never have been able to access because much of the solar system has changed since it formed 4.5 billion years ago. And the comets and asteroids, these small objects in our solar system have remained relatively unaltered since then, whereas the planets themselves, and the sun especially, these have changed quite dramatically over that time. So if we're going to learn about where our solar system fits into the universe, to the galaxy, compared to other stars and planets, then comets and asteroids are kind of a key thing to study in order to determine how we our place in that puzzle.
Mike, can I ask a quick question?
Yeah.
What is your motivation to become a comet expert?
Oh yeah. So comets are just really fascinating things. It's especially interesting to me because they are really complicated. So there's lots of different ways to study them, and there's lots of different ways to understand what they're made out of, how they behave, and we know a lot about them, especially because we've sent spacecraft to them, and we've even had spacecraft return pieces of comets to us. But that just kind of enriches our knowledge and the mysteries that we want to just understand better in order to get at what they're made out of and how they can teach us about the early solar system and other places. Mm-hmm. Yeah, we know about 3,000 or 4,000 comets over the history of science, I guess. Mm-hmm. And there's many more out there. A lot of them, they come from the edge of our solar system. They come from the Kuiper Belt disk. They come from the Oort cloud. These are the biggest parts of our solar system. Mm-hmm. And there's lots of objects out there just kind of dormant and slowly moving. And someday one of those comes in, gets closer to the sun, they warm up and produce a tail. And that's when we call it a comet. It's at that moment when you see it, it's all warmed up and losing material. Yeah.
Wow, I didn't know that many.
Yeah.
Probably. Yeah, there are a few names. Yeah.
Yeah, there's some famous ones, but there's lots more, lots of small. Yeah, it changes with time. For the Oort cloud, which is like a light year across, so it's the biggest part of our solar system, and that's kind of the edge of the solar system. And they're so far from the sun that the gravity from nearby stars and the gravity from the galaxy actually can change their orbits. And so how that changes over time, it's pretty interesting and complicated. Yeah.
Oh, okay.
And then I remember that you have a family tradition, like when you watch Comet,
yes.
You always eat donut, right?
Yes, that's
yeah.
right.
Yeah. How that tradition comes from?
I think, I don't know. I don't know exactly which comet it was, but it may have been Halley's Comet. It may have been a different comet. But my dad was an amateur astronomer, and we went out early in the morning to see a comet. We saw it, and afterwards we had donuts. And I was a little kid, so this would be in the 80s at some time. So I decided if we see a comet, we get donuts.
He sometimes bring donut like when he's like watch.
Yeah, this is a picture of a comet that I took with the James Webb Space Telescope. And it is a comet that lives in the asteroid belt. There's only a few of these that we know about, and we don't know exactly why they're there. They may be because the asteroids they're formed close to the sun, and a lot of them, if they had water, they lost it all, or the water reacted with the rocks. But a couple objects like this one they actually look like they're comets, which means they have ice on them, water ice specifically. So this is an image I took while I was studying this comet to determine what they're really made out of, and yeah.
Wow, amazing.
Yeah, it is the real shape of 67P comets.
Yeah, This is comet Churyumov-Gerasimenko, which the Rosetta spacecraft from the European Space Agency went to visit and studied for 2 years. So we have a fantastic shape model of what the nucleus looks like. This is the only a couple kilometers across. This is what every comet has at the center, although it'll be different shapes and things. But this is the thing that gets warmed up by the sun and then loses gases and dust, and then we see all that other material as the comet.
When it moved, this also spin it?
Yep.
Sure.
This spins around and kind of like this. Kind of like this way. Yeah. So if it's a duck, it's falling like head over body. Yeah.
Very exciting.
Actually, it was always that people like to know what is
Yeah.
the
What is up there.
sky.
Yeah, what is up there?
So that's why I can say I had many public lectures, and people are always very interested in all objects in space and all space missions. So something in our nature that we are curious about. I work at the University of Maryland already for 20 years. Before I worked at the University of Florida, before in Germany at Max Planck Institute, and before that in Ukraine. So I have a long career, but it was always my main interest was cosmic dust. And sometimes when you say, study cosmic dust, people say, dust, something dirty.
Yes.
But actually everything was built from dust.
Yeah.
So dust was in the beginning of the universe, and then dust produced stars, produced planets, and dust continue being produced when supernova explodes and new dust come. And then in the dust we found very complex organic molecules like amino acids. So probably life to the Earth also came with dust.
Yes.
So dust is really, really important topic in studying the universe.
It's a good view. Life is about dust.
Yeah.
Great.
She has also another role. You are the manager of
in the past, people usually just publish papers, and this is how we know what is going on. But now, so many researchers and space missions and labs produce results that it required some kind of organization. And this organization was started by NASA. It's called Planetary Data System. And people submit their data specifically from space missions so that they never get lost. Like, I don't know if you know, from early lunar missions, some data just were lost because they were on some magnetic tapes, and magnetic tapes, they don't live long. So this is why now NASA really very seriously watch planetary data systems that we say no byte left behind. You probably know this expression, no child left behind. We say no byte left behind. So all information is saved for future generation. And I can say that we have some data on comet Halley. It was in 1986, so it is how many? 40 years ago. And we see young researchers come and use those data, 40 years old data. They are still very important because, Comet Halley return in 30 years, so there are no other data. And so I'm an archive manager, so I kind of supervise this data submission, data preservation, and data access. So this archives, this planetary data system, is open resource. Anybody in any country can, without password, without registration, just go to our data system and get the data.
Oh, that's cool. I
Yeah,
like
to
to see.
leverage some like data sets from space missions, we are actually focusing on small bodies missions, but
Yeah, specifically at the University of Maryland, we focus on small bodies that are comets, asteroids, and actually cosmic dust too can be
Yes.
considered as small bodies. So this is our specialty.
So, in terms of a small body, do you have a kind of minimum? How small is it?
Oh,
Oh, dust is too small, but I think.
it can be anything
Oh,
that is
anything.
not planet, moon.
Oh,
no,
okay, that's
yeah,
right.
not
Yeah.
star, not planet.
Okay, great.
Yes.
Yeah, well, there are even for example, rings.
Yeah.
They consist of dust particles.